Hello everybody and welcome back. Today I will show you how to implement this. A screen for login and registration and toggling between those two screens. Just the UI and the interaction. No API calls, no connection to a database. So if I do not have a login, I can go to the registration screen and I can go back. I can log in with my name and a password. I can show my password or hide it. And so far, login is not working because I do not have a database connected. So now you know the goal of the video. I will shortly tell you something about my motivation to record these videos. And then I will share my tips and workflows and learnings to implement what you just saw. I will also discuss and share my thoughts about architecture, and then we will have a look at the code. You will find timestamps in the description below, so feel free to jump to the points of your interest and skip the things you're not interested in. My motivation to record these videos is first to document what I've learned. Unity has so many things to set and properties and checkboxes and possibilities to click somewhere that I think a video is better than writing many notes. And second, I want to give my students who will work in the next semester on this open source project a good start into Unity and how we use it in this project. I shortly wrap up the last video. Sorry, it was a bit chaotic and long. Whenever you use UI Toolkit, these are the main things you have to do. You add a GameObject of type UIDocument to your scene. You set the source asset to an UXML file. And you add a MonoBehavior script for the interaction. Let's start with the first tip or workflow. Within each tip or workflow I develop for myself and recommend has the following structure. I shortly describe the problem, then the workflow, and then we have a look how to do it in Unity. If you work as a team with Unity, most likely you will run into merge problems. Working in a scene with many people at the same time is almost impossible, and most likely you will run into merge conflicts. So I suggest you take your target scene where you want to work on, make a copy of it, add your game objects and configure them. Then when you reached a good state to share with others, you create a prefab from your game objects. Then you use the Unity editor to drop those prefabs or instances of the prefab into your target scene. If you have many game objects in a scene, use empty game objects to give it a structure. Remember, if you want to navigate from one scene to another, you need to add the scene to the build settings. So within Unity, take your target scene, simply copy it, name it, for example, TMP for temporary, and all scenes you want to navigate to, add them to the build settings. Just add the open scene and you're done. Let's say you create a new UI document. You do all the UXML and scripting stuff here, add the components and configure it as you like. And when you're done and everything is as you want it, you can simply drag and drop it into your assets folder. Now you have a prefab, a template, and this game object is blue now, showing it is an instance of a prefab. Prefabs are widely used in Unity. Have a look at the manual. Now you could go to your game scene and drag and drop your prefab into your target scene and create an instance there. Let's come to the second workflow or tip. Again, you work in a team on one UI because in one scene you have one UI document And if you want to work in parallel on different parts of your UI, it's good practice to split the UI in several UXML files. Unity also follows the approach to show and hide parts of the screen and not create and destroy elements. So as you can see here, the login and the create account are in the same UXML file, and that's well done in Unity using the template structure. So first you define a template, and then you may create one or more instances of this template. So first add a GameObject of type UIDocument to your scene. Discuss the naming conventions for styles and names of your controls. Define your theme and in main USS your variables and main styling of your controls. Then you identify parts or model screens of your UI, whatever you need in this scene. Split them into separate UXML files. Within the UXML file of your UI document, define those templates and then create instances as you need them and where you need them. Then you implement the logic to show and hide these instances. I will go straightly to the next workflow because this manager needs some thoughts before we can continue. Whenever you work with the UI builder or UXML, be careful what you do in UXML in Rider and what you do in the UI builder. So I suggest you start in the UI builder to get your UI mostly as you like it. Then you take out the inline styles and put them in a separate USS file. And remember to reuse the variables you defined in your theme. Then you work with the UXML file and Rider, clean up the file, give names to the controls, use the classes, and forget about the UI builder. Be careful if you open the UXML file in Rider and work with the UI builder side by side. I almost lost 2 hours of work because they did not work well together. So I suggest really close Rider if you work in the UI builder and close the UI builder if you're working Rider on UXML files. So whenever we want to implement something, we need some thoughts about architecture. The problem again, you work in a team, you need to split work and work in parallel. And if you do not discuss and plan your architecture properly, you will have many changes and discussions on the way. And how do you plan an architecture? First, you study design patterns of the technologies you are using. Then, for example, in Unity UI Toolkit, you study the examples provided, like Dragon and QuizU. And then you plan your components and files and the communication and the interfaces. I come from the .NET world, and Unity uses C#, so I thought I will have a try with the model view model pattern. So with the model view model pattern. The model does all the communication with the database. The view is described in XAML, similar to UXML in Unity. So you have all the controls, and during compilation, this declarative description of your UI with the concept of partial classes and a code behind file is used to create one class where you have the members of your UI, and within this pattern it's very simple, it's almost empty. Then you have the view model, which does not know anything of an UI, so you will find no references to UI classes in the view model. It defines properties which may be used by the view and commands to save data to the database and so on. This approach is very powerful because it makes testing very easy, because you don't have any relation to the UI, and of course it fulfills the separations of concerns. So now comes the interesting part: how do they communicate with each other? This communication is in general very easy. You use some sort of dependency injection, like you pass an instance of the model into the constructor of the view model. Now comes the interesting part. You use data binding to synchronize your properties with the controls of your UI, like you enter name, the property name will be changed. This exists in Unity since 2023, so great. And in MVVM, you use command binding, where, for example, you bind a button of your UI to a command in your view model to save data into your database, for example. To do so, you really don't need any coding in the view. You simply defined in your XAML file your binding to the command here, and your XAML file knows the data type to support IntelliSense and so on. It works really well and makes the view model completely independent of the view. Unfortunately, I haven't seen any plans to implement command binding in Unity, so good idea, but it will not work. Then I studied the examples Dragon and QuizU. By the way, the Dragon example provides, both examples provide great documentation in the PDF. You find the links to the examples as well as all other links in the README of the GitLab repository, where I provide all the code I'm showing here. So we have this QuizU, and we have a real game. The Dragon crashes, and I check the code and this documentation. They work a lot with ScriptableObjects to pass data from one part of the UI to another part of the UI. So whenever I try to understand concepts and architecture, I sketch. So within Unity, we have a scene. In a scene, I may have one game object of type UIDocument, and attached to this game object, you have a UXML file, and you can create instances of other UXML files in this main UXML file, and you have attached one manager file extending MonoBehavior. So that's the general structure, whatever you're doing with UI Toolkit in Unity. In Unity, we do not have this code generation from the UXML file into partial class and everything is wired up automatically. The thinking is more like in the web, where we use something like document get element by ID to get an object of the document, and then, for example, we have a button where we add event handlers. So what they do for each separate UXML file, they create a class called view, for example, navigation view, settings view, and so on. There they have the controls as members, and there they implement the interaction. Each view is created from the manager and gets the top element to do this query stuff to get the controls as a parameter. So this top element is a visual element. And then they define events, more precisely multicast delegates, and the manager listens to these events, or in most cases the manager listens, and the view invokes it. Like I pressed on the login button and the manager has to decide what happens next. This is possible because these events are defined as public static. In addition, they might have some other events where some special controller classes do something with the model. And these controller classes, they add as game objects to the scene. So we first start with this main architecture, and if this is not sufficient, we think about the extension with the controllers. So let's see how we may apply the approach we studied here for our problem to toggle two screens. Whenever you plan UI and interaction, it is always a good approach to start with a paper prototype and then go into more detail and develop with Figma or a similar tool a digital prototype. As a result, you know which controls you need, which interaction, which screens, and how you may split them into components. So within our scene, we will have one game object of type UIDocument. This we will call login register UIDocument. Attached to this, there is one UXML file we call start.uxml. And attached to this, there is one manager extending MonoBehavior, which we call LoginManager. Now we have to discuss which views we need, meaning how to split up this start.uxml in different parts, and which events we need so that the view and the manager may communicate with each other. So first, we take our start screen. So to be able to answer the two main questions, which views do we need and which events, we take our start screen, and obviously we will have something like a login screen and a registration screen, and the manager should be able to toggle these screens. So now let's think about events. So let this be our UXML file describing our UI and the login view coding the interaction. So obviously, whenever we click on this login or on this login as guest button, the manager should navigate to the game scene or any other scene. So we have something like a login event. And if we think of register screen, we most likely will have something like register, where either the manager just toggle the screens and goes and shows the login screen, or goes straight into the game scene. But that's the decision of the manager and not the decision of the register screen. In addition, we need to know when we have to toggle the screens. So if you press on this one or similar one here, again, the manager should decide how to handle this event. So we need some sort of toggle, or call it login screen selected. Now the manager could easily show and hide these visual elements, but maybe the login view has to do something on the toggling on the hiding or the registration screen. So in this case, I decided to be able to set some visibility in the view. So after these considerations, we know we need some sort of login screen UXML and some register or registration screen UXML. And we have the events login, register, and login screen selected with a Boolean. In addition, our view or our views, login view and register view, will need a method SetIsVisible. We take the example of the login view. The login view is able to invoke login or login screen selected, for example, to set it false to show the register screen. And the manager listens to these events and handles accordingly. The login view has all controls as private members, and obviously it needs a method SetIsVisible. And the login view is created by the login manager with the top element of type VisualElement, which holds all the controls of the login view. So we have a constructor which takes a VisualElement, which we call top element, and will be a member of our login view. And then we will fetch our controls and assign them to our private members. This we will separate in a private method called setVisualElements. In addition, we need to implement the interaction, which we will do in a method called register UI callbacks. So that should get us started well. So first we start up Writer and create folders and files like images for this iImage and /iImage to show and hide the password, a folder scripts where we have our events, our extensions, I come to this in a second, the manager class and the UI view classes. in USS we store all the style files, and in the folder UXML all the UXML files. So first we fetch the images, I and I slashed. For example, you can go to the Google Fonts pages and search for the I, and then you download it as a PNG file. Then we create a file LoginEvents. This has to be a static and declares public static action events, login, register and login screen selected with a parameter of a boolean. Action is a predefined delegate, predefined by .NET. More precisely, it is a multicast delegate, which means you can add and remove pointers to methods. So this multicast delegate contains a list of assigned. So this multicast delegate contains a list of assigned delegates of function pointers. And whenever I invoke this list of delegates, each function pointer of this list will be called. There is no need to declare your own delegates, as action and func, a delegate which returns a value, will cover all delegates you might need. Then we define an extension method, so we add additional functionality to the type VisualElement, which we call SetIsVisible, and this takes a boolean. And in UI Toolkit, to show an element, you set the style display to be display style flex, and to hide it, we define an extension method for the text field to show and hide the password. There is no separate password field, but the text field has a password attribute, and in code it's called isPassword field to be true or false. And we will toggle between two classes, iIcon and iIcon slashed. And to toggle these classes, we remove the current class like iIcon and add iIcon slashed to the list of classes, and the other way around. So we need to define these classes, which we do in login register screen USS. Of course, you have to add this file. And here we set the background image to iPNG or I/PNG. To define the look of an icon, we need to add some further properties and not just the background image. For example, it is good practice to set it to a good height and width. Then we have to define the class LoginManager and the classes LoginView and RegisterView and the corresponding UXML files like login screen, register screen, and the start screen. So for the start, it is sufficient if the login manager extends MonoBehavior, and we can implement the functions later. So after creating all the files, you go into Unity Editor. I recommend to add an empty GameObject to structure your GameObjects. Usually in a game you have many of these GameObjects. Then you create a UI document, give it a good name, and drag and drop your start screen to the source asset and use add component to add the login manager to your UI document. Now you're set up and you can push this scene to your GitLab repository, and everyone else can continue to work on this scene while you implement the interaction. So you will start with your UXML files, for example with the login screen, and the register screen will look very similar. And then you take these screens, define them as templates, and create instances from these templates for your start screen, which belongs to the UI document. So we have a control with the name login screen and a control with the name register screen. In our login manager, we will define the UI document, the login view, and the register view as private members. And on enable, when everything is set up and available, we will fetch the UI document, we will set up the screens, and we will subscribe to our login events. On disable, we need to unsubscribe from the login events because they are static and they live longer or might live longer than this object. So it's always good practice to subscribe and to unsubscribe. So in setup views, we fetch the root visual element, fetch login screen and register screen by name, and create instances of our class, which we will implement in a second, login view and register view. We subscribe to the events, to the login events, login, register and login screen selected. And in the next video, we will need a subscription to the logout event as well. On login, for example, we navigate to the main menu scene and we hide our views. On register, we basically toggle the screens. This means we set one screen to be visible and the other one to be invisible by calling SetIsVisible with true and false. So that is all we need in the manager class. Now we will have a look at login view, and register view will be similar. So here we will define all our controls, buttons and text fields and labels we need as private members. We get the top element, so this one, which holds all this as a visual element in the constructor. And then we set up our visual elements and register all UI callbacks to implement the interaction. So in set visual elements, we fetch by querying the top element all our controls by name. And in register UI callbacks, we add handlers to clicked events. And for example, for the label, which has no clicked event, we call register callback click event and pass the private method show register screen. In addition, we need the public method SetIsVisible, which is called by the manager class, and we show or hide our top element. And in addition, we have an error label, which we show when an error occurs, like login and password do not match. So we make sure this is invisible whenever we start again. Here we call the extension method we defined earlier, TogglePasswordVisibility. Here we invoke the login event, and in login we could call a data manager, which might be implemented as a singleton, and call the login user function there with our text field values. And as I did not implement in this project a data manager, I set it to false to show how you might show errors to the user. Then we have this show register screen where we invoke the login screen selected event. So that was all we needed to do. Run the application and adapt it to your needs. In the next video, we will see how to implement a menu like this one and how to pass data from one scene to another one using scriptable objects. See you then. Bye bye.